गुरुजी आ जाओ क्लास में।
Hi, hello,
Yes, sir.
hello. Did
Uh,
someone say something? Yeah.
yeah.
Guys, attendance enabled.
हेलो। अरे कैसे करने की तुम कोशिश कर रहा हूँ, कैसे मतलब अरे वो तो दिखा रहा है स्पीकर कट किया। लीव कर दूँ।
Guys, the attendance is enabled, so please put it. So, are you guys facing any issues with WebEx today in other lectures?
Yes, sir.
Right?
Yes, sir.
Yeah. So the same problem is at my end as well, because I could see that internet speeds are fine. I mean, I constantly check the internet speeds, and yet sometimes either I cannot hear you or you may not be able to hear me. So it's the old WebEx back to that. That is the problem. So I think, unfortunately, we don't have any other option. Okay, so I think this the attendance is not going to improve by much, so we can probably start. Uh, Put the attendance, guys, if you are there and have not yet done it.
Okay, sir.
Okay, so let's start. Yeah, by the way, if uh, so, I really don't know what is the best way to do this, because if my voice breaks, okay, let me do it like this. I will not go into the full screen mode. Um, Maybe for just one or two slides, I will go in the full screen mode. Um, Otherwise, but yeah, even then I need to check the chats. Okay, let us try to do this today. Because if the voice breaks, the idea is I want you guys to tell me. But the problem is that if the voice is breaking, even
But your
if
voice is
you
fine like this.
okay, as of now, right? But it happened with the previous lecture that in between for some 1 or 2 minutes I was not audible, but the students tried to tell me by unmuting, but I could not hear them as well. So it was a kind of a system where there was no way I could have been given this feedback. So what I'll do is, like, I'll keep on checking the chats after each slide. That is probably the best solution I can give, uh, because WebEx is WebEx. We can't do anything with it. Okay, so let's start, guys. Okay, so I hope like it's visible to you. There are some slides with code, so for that I will try to probably okay, let's see. I'll try to magnify it and see. I hope you guys can read the text in this mode itself. Um,
Yes, sir.
Yes, sir.
okay,
Yes,
yeah.
sir.
So okay, so let's start in this mode itself. I'll keep on, or maybe I can actually do it like this as well. I can just do Alt tab, yeah, Command tab. Okay, I'll keep checking it once in a while. So if there is an issue, please at least try to unmute first and tell me. If I cannot hear you, or if it doesn't go through, at least put it on chat. I'll keep checking the chat periodically. Okay, let's start then. So let me go back to this slide first. So you know that the name of the subject is object-oriented methodology, right? So the term itself means that it's a methodology. Okay, it's a verb. It is something that it's part of a process overall, right? So what exactly is this object-orientedness? This is the topic of discussion today. So this whole concept of object orientedness is a part of designing my software, right? So you remember that in SDLC there were some phases, right? There was this requirement analysis or planning or whatever you call it. Then there used to be some designing and then some implementation, testing and deployment, maintenance, all those things. And I said that in this course we are going to put some more focus on the design phase of that SDLC. And so object oriented modeling refers to an approach towards designing software. Okay, so now you can understand where the pieces are going to fall. Okay. The overall idea of object oriented programming is that you are going to model your software in terms of objects. Okay, what exactly are objects, we'll discuss it in a little while, but this is the overall idea that I want to represent my software in terms of collaborating objects. Okay. Now, if you remember, I said that during this phase of design, basically we come up with some documents, okay, and these documents are going to be kind of a guideline for my implementation step. So whenever I start with the implementation of the software, these design documents are going to help the software developers, my programmers or whatever you call them. They are going to use these documents and build the system overall. Okay. The most common forms of design documents are some sort of diagrams. Okay, one example we saw in the previous lecture, that was of a class diagram. There are other types of diagrams as well. So now another major challenge right now is that in the industry standardization is still a problem. Okay, so different people come up with different types of conventions when they create these diagrams. Okay, and the actual meaning associated with the boxes and the lines that they draw in the diagram, many a times it's not clear. Okay. Still, there is at least a standard out there called UML, which provides a specific interpretation for all different types of boxes and different types of lines. Okay, basically the connectors that you can call them. So UML is there, it does provide a nice standardization for the conventions for creating these diagrams. Unfortunately, it's just that UML is often ignored in industry. There are some companies who are very strict with it. If I'm not wrong,
So your
IBM.
voice is breaking.
Okay, sorry. Let
Clear?
me
No,
correct.
no, his
It's
internet
fine from my
is
end.
No,
Oh, sir, it's
no,
clear.
sir,
Clear,
it's
sir.
fine.
Sir, it's
See,
fine.
this is, yeah, that is the problem. It is actually, I think, a WebEx problem, if I'm not wrong, because sometimes I also hear these beeps, no, the beeps that you hear when a new person joins. This sometimes the beep is absolutely clear, and sometimes the beep is fluctuating. When it is fluctuating, I realize something is wrong. Um, but I don't know, right? So anyhow, let me go back to this part. So basically, the UML, is it clearer now, guys, for those for which it was breaking? Usually, it's a temporary thing. It will happen for maybe 30 seconds, and then it should get better. So has it gone better? Has it become better?
Yes, sir.
Okay, yeah. So that is the thing, that it is some kind of a temporary, I'm not sure what, some kind of temporary problem with WebEx, and within a few seconds it resolves itself. Anyhow, so so UML is a standard which actually gives standardized interpretation to these boxes and lines that you draw in these diagrams. Okay. And how does it help? If I give you a diagram that follows UML conventions, you can, without actually explaining it to you explicitly, just by seeing the diagram, you can understand what it means. Okay, what are the different elements in the diagrams, how are they connected to each other, what is the relationship between them. All this becomes clear to you, provided that the diagram has been like I showed you a diagram in the previous class. it does not conform to UML conventions. Okay, that is why I said it is not so perfect. um, the problem with UML, on the other hand, is that UML actually is in some ways a bit tedious as in it takes time for you to adopt UML. Okay, there are so many conventions and there are so many things that you have to remember that sometimes, even if you want to uh, represent a very simple concept, if you go by UML, there has to be a certain type of a box, there has to be a certain type of line, and over a period of time, you just tend to ignore those standards because it's probably easier for you to write a one-line explanation for the box or a small annotation over the arrow rather than trying to follow the convention. But anyhow, the advantages of learning UML, or at least trying to learn UML, is that it becomes easier for you to interpret these diagrams. Okay, when someone gives you these diagrams, it will be slightly easier for you to interpret them. So this is why we are going to uh, check up all these things later in this course. The overall idea is that you learn these things so that you can easily interpret and create these kind of diagrams. Now, why exactly do we need this object-oriented modeling approach? Is there an alternative to this? Well, there is certainly an alternative to it. You studied that alternative in the previous semester, right? So in the previous semester, whatever code you wrote, you did not use any classes and objects, right? So it is certainly possible to build systems without using anything related to object orientation. Okay, but what is the major advantage of using object orientedness? The first point is that it aligns very well with the real world. Okay, what do I mean by this? If you remember the example that we saw in the previous class, there was a student class, there was a course class, and there was a faculty class. Now, it is quite easy to actually imagine such a system, such an ecosystem, because in the real world it is like that only, right? There are students who register for a course, there is a faculty member who's teaching that course. So it all seems very natural, right? From the real world, the transition into, let us say, the programming world is somewhat straightforward. So this is why the object oriented world, the object oriented design methodology, is very popular, because it is a natural extension of our real world. The second aspect, of course, is that from the perspective of programming, almost all general purpose programming languages today, they have support, if not full support, at least partial support for object oriented paradigms. So you can create classes and objects, for example. So this means that overall it's a good, by the way, object oriented programming is different from object oriented methodology. They are often used together in the same project, but in theory, it is possible for you to design your system using the object oriented methodology, but at the time of implementation, you somehow map it to C code, for example. Okay, so they are two different things, but usually they are used together, because as I said, these are natural extensions to each other. Okay, so now the other alternative to this object-oriented programming is structured programming. You have already done structured programming in the previous semester. Okay, so C is a language that does not support object-orientedness. So whatever code you write in C is basically structured programming. Now, in this approach, the major difference between this structured, I don't think there is a term like structured methodology or structured design, but you can understand what I'm trying to say, that if you are using structured programming, the major difference between what you are going to have, let us say, as in comparison to object oriented programming, is that in this approach you basically decoupled data from the operations over the data. Okay, so let me give you an example. If you remember, in the previous semester there were some examples where we had a structure for car, right? And then the car used to have a name and then some other attributes, I think price or something like that. And based on that, you will actually do something related to that. um, how exactly were we trying to operate over these structure variables? I think if I'm not wrong, we created a function, okay, and to this function we were passing the structure variables, and then whatever operations we wanted to do with the structure variables, we were simply doing things like structure variable dot member variable equal to something, in this order. So basically you pass the whole structure variable to a function, and then you manipulate it or read it or write it, whatever it is. So essentially these functions were in some ways independent of the structure itself. Okay, this is the idea, that the data was decoupled from the operations that were going to happen over the data. um, in object oriented programming, the major difference here is we are now going to associate data with its operations, or vice versa, operations with its data. Okay, so basically we are going to create a cohesive unit where data as well as any operations associated with that data is going to be the part of the same cohesive unit. This is the major difference between object oriented approach and structured approach. Now another issue with structured programming, and this you would have already seen in the previous semester, that there was no concept of privacy of data. Let me give you an example. Assume that you are operating over Facebook, but for one day, Facebook has switched off all its privacy settings. Okay, so whatever photos you add, whatever posts you write, basically it is public. Okay, anyone on the Facebook can come to your page and see everything that has been written there, right? So this is in some ways what structures are. There is data. Certainly you can have all types of data within a structure, but it's public. Everyone can use any function which gets access to the structure variable, can easily modify or read any member variable. There was no concept of privacy. But now assume that now but now come back to see what Facebook actually looks like. If you upload a photo, you have the option of either keeping it completely public, or you can say, just share with my friends. You can say share with everyone except X, Y, and Z, or share just with X, Y, and Z. There are so many levels of privacy settings that you have, right, which you can tweak for at the photo level, right, or at the post level. You can go and tweak these things, right? But with structures we could not have done this with the member variables of the structure. So this is an example, guys. It's is it visible? I mean, okay, yeah, I'm in full screen mode. Okay, so so basically let us just see the code on the left side first. Okay, this code you should be able to easily understand. There is a structure called person struct. I have used a type def with it, so now I'm going to call it just person. I'm creating a type of this person called player, let us say, whose name is Rohit and Sharma. There are just two things, first name and last name. And then I have written a function called print the last name of the person. Okay, and this takes up an argument person p. And for now, just don't just ignore this part. This is the task of this function. Just print the value of p, whatever was passed to it, dot l name. This is what this function is trying to do. But you can see that there is actually there is a problem here, that even though this function is doing what it is supposed to do, it is actually free to do something like this as well. Okay, so even though I am expecting that the only value this function is going to change or access is the l name, the function also has access to the f name. Okay, and again, I'm not even talking about malicious intent where someone is maliciously trying to access a field. It could be a mistake. Okay, let us say it could be a typing mistake. Instead of l name I just typed f name or something like this, right? Some auto correction mistake in IDE, whatever it is. So what happens is, if I actually mistakenly write some code which accesses or modifies some other field of this structure, there's really no way for the compiler to know, right? I mean, and the reason here is that structure in some ways is a dumb data type. It's basically a dumb collection of data. Okay, and there's really no privacy. There's no control of you over what can be what is accessible to a function and what is not accessible to a function. Now let us see the code on the right. By the way, the code on the right is in C++. The code on the left was in C. Now I understand that some of this code you will not really get, what exactly is written here, but still, for now, just concentrate on these private and public terms. Okay, what exactly do the private and public terms mean, that we'll have a look at later. But one thing that you can see is that there is a concept of being something, of making something as private, and there is a concept of making something as public. Okay, this is the first cue. So this is the first hint that you get here. This is how what is going to differ in a class and a structure. That in class you can create something known as a private thing, and you can create something that is a public thing. That is the first uh, idea you get from this code. Now, if you actually see whatever is written here, basically it looks very much like a structure, right? Instead of struct, I have written class here, and it looks very similar to the structure. I have this char f name 20, char l name 20, and but there are certain things which are added here. For example, there are some functions written here, right? And this function is actually within the boundary of the class. Okay, the same block that is there for class, these functions are within this class. They are not here, for example. Okay, they are not a peer of the main function. They are in some ways, a part. They're in some ways a child, or and they're children of this class thing, right? This is the difference that you could see here. So the idea is, these functions define some kind of operations. What are the variables they are using? You can see that these are the two variables that are being used here. Essentially, these functions are operations which are going to work over these member variables. So without actually wasting much time, let us just get to the definitions first. So a class is a collection of related data items together with some operations over them. Okay, in contrast, a structure only groups data items. It does not have any operations. So that is the first difference you see. That basically, there is one way to look at a class, is that a class is a structure plus some functions or operations, that we call them. Okay, a class consists of two types of members. The data items which we used to call member variables are now known as fields. Okay, so this is the new term out there, that the member variables of a class are known as fields, whereas the functions that we just saw, some two or three functions, they are called as methods. Okay, so these are the two new terms that are coming into picture. Fields are basically the same thing as member variables of a structure, and some specific type of functions are also going to be a part of the class, and we are going to call them as methods. Similar to the structures, classes are also just templates. Okay, when you create a class, no memory gets allocated for it, similar to how that structure template was, right? Memory is allocated when you create a type of the structure variable. Similarly, if you create a variable of this particular type, of this particular class, it is called as an object. Okay, so an object is an instantiation of a class. Okay, so if class is a type, an object of the class is a variable of that type. Okay, so basically an object is equivalent to a structure variable in some ways. Okay, and these operations that I wrote, these functions that I wrote, are basically a kind of function which can use the fields. Okay, the fields that are defined in the class, similar to how a typical function uses global variables. Okay, in a typical C function, if there was a variable that was global, it was accessible globally. Whatever changes you make to it, it will be visible in the other functions. So these operations, they work in that same fashion, that all these operations are part of, let us say, an ecosystem where all the fields are available to them like global variables. If they make a change, if one function makes a change in any of them, others can see it. And it's like two or three global variables out there. Okay, so this is the first cut difference between classes and structures. Don't worry, we'll start with some coding examples
Sir,
tomorrow. Go ahead.
sir, does in Java, sir, declaring classes occupy memory?
No. Classes are always templates. Okay. Um, Unless you have, let us, there are some peculiar cases where you have static variables and all. In that case, in Java, whenever you load the class using the class loader, some memory has to be allocated because for the static variables, even without an object being created. But in general, if you don't consider the static variables part, classes are just templates. Memory is allocated when you create objects. Okay.
Okay, sir.
Yeah.
Thank you.
So uh, okay, coming back to the point. So don't be worried about the cut terminology. Let us first see some examples. So I'm saying that automobile is a class. Okay, and the objects of automobile are Volvo B8R, by the way, is a bus. Rolls Royce Phantom, it's a car. Harley Davidson Iron 883, that's a bike. Okay, so I'm saying that the class is automobile and objects are Volvo 8, these three things. Similarly, I say the class is movie and the objects are these actual movies, the Shawshank Redemption, Interstellar, Bahubali, and all that stuff. So this is the difference. This is the class and this is the object. Now for automobile, fields, okay, what are the fields? Basically, fields are in some ways the attributes of this particular entity in the real world. Okay, what are the attributes of a particular vehicle? When I talk about a vehicle, what do I say? Oh, it's a two-wheeler, it's a three-wheeler, it's a four-wheeler, or some kind of n-wheeler. So probably the most important property of an automobile is the number of wheels. Okay, it will be different for different types of automobile. Another type that is very common is fuel type. So is it a petrol car? Does it run on diesel? Does it run on CNG? Okay, so that's another attribute of this automobile. And the fuel capacity, what is the how many liters of fuel can it actually store there? So these are some attributes of an automobile, and in our case we can consider them as fields. Operations, what are the things that you can do, or that you can do over an object or with an object, something like this. Okay, so for example, what can you do with Volvo B8R? You can drive it, you can add fuel to it, you can inflate its tires, so on and so forth. So the difference between operations and fields here are, fields are basically nouns. Okay, and these operations are essentially verbs. Okay, you are going to do something with the object, so these something are going to be the operations. These verbs are going to be the operations, whereas the attributes are in some ways the nouns, they are the properties. Okay, so they are the fields. So in case of movie, for example, the fields will be things like the name of the movie, the release year, the viewer certificate, whatever it is. Okay. And what are the operations? You can stream the movie. You can download it to your device. You can delete it from your device. So this is the difference, verb versus noun. Fields are nouns, and operations are verbs. You do something with those fields. That is the idea. Okay. And one more aspect here is, these objects can be hierarchical in nature. Okay, so let us take the example that let you're going to have another class called streaming platform. Okay, what is the example? What will be the object of streaming platform? Prime Video, Netflix, Hotstar. Okay, so this is the class streaming platform, and the objects are these Prime Video and Hotstar and stuff like that. Now, what exactly would probably be the fields of this class. um, so what do you do with when you go to a streaming platform? You probably search for a movie. How do you search for a movie? By its name, viewer certificate, or something else. Some There are some properties associated with a movie, and these streaming platforms allow you to search a movie based on one or more of these properties. So actually, in it is quite possible that if you see streaming platform as a class, this class will have a field called list of all available movies or something like this. And what exactly is this field? It is essentially an array of movie objects, right? So basically this array will contain the Shawshank Redemption, Interstellar, Bahubali, all the movies. So each object will represent an actual movie. But this class, what I'm trying to say is, it is basically a collection of fields, and each of these fields could also be another object or a collection of another object. So that is the idea. And now you can see that there is a hierarchy here. There is nesting, and this is why it is possible to simulate, or this is possible to design a very complicated software system with the help of this hierarchy. Okay, that one class can have another types of another class as its members, as its fields. Okay, so now if you go back to this class, this example again, now let us try to see what exactly is it. So person is a class, and player is an object. Player is an object of type person. Okay, and these set f name, set l name, print last name, these are the operations, and f name and l name are the fields. Now one thing that you have to understand is, these operations, you cannot simply call, let us say, set f name directly. Okay, it doesn't make any sense. It's an operation that is specific for the objects of type person. Okay, this is why if I want to call any of these functions, I need to put object dot before the name, right? Something like here, it's not visible, player dot set f name, player dot set l name, player dot print last name. It is so essentially, now you are going to access these functions similar to how you have been accessing the member variables. Okay, so even if you want to call these functions, you need to associate them with a particular object. Once you do that, let us say, once I say player dot set f name, and when the program control reaches here, I can simply write f name. I don't have to write player dot f name here. Why? Because that player dot part is implicitly provided here, right? That which f name are we talking about? We are talking about the f name associated with player. That is the idea. Okay, this is why I don't need to put any qualifications here. I don't need to put x dot here before f name. I can simply use f name, l name as if they are some kind of global variables. Okay, so if you can understand this much part, this is the overall idea of a class and a structure. Don't worry, tomorrow I'm going to show you some more parallel codes like this. Okay, so if you have any confusions, it will probably get better tomorrow. You can see the contrast between the same code written in C and the same code written in C++. But this is the overall idea. In a class, there are some data items. We call those data items as fields. Then you also have some functions. We call these functions, operations, methods, whatever you call them. These methods operate upon these fields, and if you want to access these methods or these fields, you need to use this dot operator. Object dot and either the field or the method name. Okay, so this is the overall idea of a class. We'll keep on looking at some examples tomorrow. Not okay for you, it is tomorrow, I think. For the other batch, it is on Thursday, and there we will have a look at some of the code, some parallel code. But any queries till now here? And by the way, this is the last slide. After that, it's homework. And please
Sir,
do.
can you
Yeah, go ahead. Sorry.
sir, can you explain the difference between structured programming and object-oriented
Okay,
programming
okay,
once again.
okay. Okay, so the major difference here is that when I'm trying to do structured programming, let's say the nouns are different from the verbs. Okay, the actual data of which I'm going to operate over in my program is decoupled from the operations that are going to happen over the data. Okay, so this is a way of thinking actually, right? It's a way where I say, um, just it's like saying, let's go to the market and bring 2 kg of rice and 1 kg of dal, and this much kg of aloo and potato and stuff like that, and you bring all the ingredients home and then you hand it over to someone else. Okay, they say, these are the groceries, go and cook something for me. You don't care how these ingredients are going to be mixed with each other, whether they are going to create a paratha or a roti, or whether you are going to have some rice dish. You don't care, right? You brought the ingredients, you hand it over to a person in the home, and your job is done, right? So the actual ingredients are decoupled from how these ingredients are going to be used. It's completely dependent on the person who's going to use these ingredients. In some ways, this is what is structured programming. Your data is separate, the operations are separate, you don't link them together. In object oriented programming, they are linked together. Okay, so you don't just bring atta from the market. You say, okay, I brought 2 kgs of atta, please cook me some aloo ka paratha. Okay, you don't basically leave things hanging in there. So the data and the operations are tightly coupled with each other. This is the difference here in object oriented programming. Whatever methods, whatever operations you are going to do on the data, that is part of the same cohesive unit. Okay, it's defined within the boundaries of the class. This is different from the structure part. You needed to write a different function altogether and then pass a variable of your structure type to that function and then write your operation there. So is it getting clearer? This is the idea that basically in structured programming, I decouple my code, my data from the functions, from the operations, whereas in object oriented programming, they are tightly coupled with each other. Is it getting clearer? And by the way, don't get
Yes,
disheartened. I
sir.
mean, right? So as you see more parallel examples of C code and C++ code, this thing will become clearer. So please go through this example today. I will at least have two more examples for tomorrow. Tomorrow there is no lecture. I mean, lecture as in there will be no slides. I'll just open up the code. I'll show you parallel codes. I'll show you how to compile. It's not too difficult. Basically, instead of GCC, you just use G++. But yeah, tomorrow we'll just have a code based lecture, and you can ask me questions at the code level. Okay, any questions, any other questions? Object hierarchy. Okay, so let us go to this example. Where is it? Huh. So now let us assume that you are being given the task of building something like Amazon Prime Video, for example. Okay, and you say, okay, let me say Prime Video is a class. Okay, what will be the fields of this class? So what exactly is it that Prime Video consists of? Prime Video consists of things like uh, these TV series, films, sport events, live streamed sport events, highlights of sport events, so on and so forth, right? So maybe the fields of this class called, let's say, uh, whatever is the name of the class, will be about the content, right? What content is this streaming platform going to have on it, right? It will be like list of the movies, list of the TV series, and the kind of events that you're going to see on this live, IPL or whatever it is. So what will be the typical fields of this? It will be list one of the possible field will be the list of all the movies available on this platform. Now the movie itself, how the movie entity itself has some more properties. What, like, the movie has a name, it has a release year, and I think it is possible on all these platforms that you can basically search them for on the basis of name, genre, language, whatever it is, right? There are so many things on the basis of which you can search a movie. So the movie itself is not a very simple string. Okay, that itself is a collection of other information, right? So this is the overall idea, that when you actually build a system using the object oriented methodology, you will see this hierarchy, that there will be certain objects which are very simple objects, let us say, which only have things like one integer, or maybe a character array, things like this. So these are very simple objects, and then you construct your system in, let us say, in a bottom up fashion, where these simpler objects become fields for more complex objects, and so on and so forth. Does that make sense? So basically this is the overall idea of a hierarchy, that a movie itself has some properties, and if you are going to have a class for, let us say, a streaming platform, that is going to have a list of movies. uh, yeah, so this is the idea, right? I mean, there will be lectures now in this course, because I received this feedback that sometimes all you guys want to see is code. So uh, actually, this week's lab will be it will be offline. Your TAs will give you will send you an email today. They'll inform you that they are your mentors, and tomorrow I'll just send you guys some C problem over email. Just try to write code for that. It is going to be a C problem. It is not going to be a C++ problem. I'll just give you a C problem. Write code for it. If you have any issues, contact your mentor. So make a, have a good rapport with your mentor. Try to, because it's like, now there will be one more person for you to talk to, not just me. There will be a TA out there who's going to help you out. So this is another change I'm doing in this semester, that the lab exams, instead of taking lab exams every week, I'll give you opportunity to simply try to learn from someone else, right? Let us say a TA, for example. So you write some code. If you get stuck, the TA will help you out, and on some days we will have exams. Okay. So no, there will be no lectures. Basically that slot is kind of free for you tomorrow. Okay. uh, yeah, sorry, I was explaining this. So this object hierarchy thing, does it make sense now? That essentially you are trying to club up information, and it could be hierarchical in nature. That a movie itself has multiple attributes, and there could be a class where you have a list of movies. Okay, and so you are capturing information hierarchically, that the information related to a movie is captured in a movie object, and the information related to all the content available on a platform, all the films that are available on a platform, is stored inside, let us say, an array of these objects. So does it make sense? Okay. Any more questions?
सर कल का सर टॉपिक है एब्स्ट्रैक्शन हायरार्की सर.
सॉरी, क्या हुआ?
सर कल लास्ट कल का जो लेक्चर था ना उसमें एब्स्ट्रैक्शन
हाँ
हायरार्की
हाँ,
एक टॉपिक था सर, उसमें थोड़ा डाउट.
कल आपको कल के लेक्चर में कुछ क्वेश्चन पूछना है, ये बोल रहे
यस
हैं?
यस सर, यस सर,
हाँ
यस
ठीक है,
सर.
मैं अभी अभी हम लोग करते हैं, पहले आज के क्वेश्चंस कर लेते हैं,
ओके.
और फिर मैं कल का लेक्चर खोल दूंगा, आप बता सकते हो. एनी अदर क्वेश्चंस फ्रॉम टुडे?
नो सर.
Okay, so let me just open up yesterday's presentation. Mm, 1.1. Okay, let me share. Okay, what is it from yesterday's lecture that you guys want to ask? What was the question from yesterday's lecture?
So levels of abstraction, sir. The last slide, sir.
Okay, this one.
Yes, sir. The
Yeah.
third point and the fourth point.
Okay, you did not understand this? Okay. Okay. So let me give you an example. When you wrote code, even the most aggressive coders, let me use the term aggressive coders. Okay. What do aggressive coders do? They don't trust someone else's function. Okay. Even if you have to write a factorial function, you say, oh, okay, I'll write my own code for factorial. I don't trust or it may not be trust it, maybe you're just too enthusiastic right now, and you might actually want to code everything. So you might say, okay, I'll write the factorial function on my own. I'll even write the sqrt function on my own. It is possible to do that. It's not that difficult. You just have to figure out that algorithm and you have to write it. But even the most aggressive coders probably did not write code for printf and scanf, right? You probably simply used printf and scanf. Why did you do that? Because at some level you said, okay, I am fine with taking inputs and outputs through a library function, but everything else I will do on my own. Okay, this is probably what may have come to your mind. So why did you draw the line at library functions? Because at some point of time I don't care about the actual details of how something is happening. Okay, I am only worried about the final outcome, right? So I want to print a message to the terminal, and that is why I will use printf. I don't care exactly how printf works. Similarly, I want to take an integer as an input. I'll simply use scanf. I don't care exactly how scanf manages the input, right? So at some point of time, whenever you write code as a developer, this will be a dilemma that will come to you multiple times, that what is this level? Okay, at what level am I going to simply say, I don't care about the how part, I only care about the what part? Okay, so this is the actual level of abstraction, that at some level of abstraction I will stop caring about how, I will only care about what. Okay, now uh, this level of abstraction, of course it depends on the programmer first of all. So you might say, I only use printf and scanf and everything else I will code on my own. Or you might say, no, I am a person who loves abstractions. So as long as there is a method, there is a library function to do whatever I want, I'll simply use the library function and I won't write my own code, right? So this level of abstraction is something that is dependent on the programmer, the developer, that what level of abstraction do you want. And there is like a kind of a relationship with the language that you use. For example, um, python or java, they actually provide you such a rich standard library that accompanies it, that you might actually be tempted to use the function rather than write the code on your own. Okay, and matlab, for example, that has such vast library, matlab, that almost anything that you would like to do in the computing world, in the scientific computing world, there will be a function in MATLAB to do that. Okay, so you don't have to write that mathematical function on your own. You can simply use these functions. C, on the other hand, is a language which provides very basic library support. Almost everything else has to be written or coded by you. Okay, you have to write the code. So as a developer, the first thing is that you should pick up a level of abstraction on your own. You know what level of abstraction you are happy with, and then it is also possible that the kind of level of abstraction you want may be possible or may not be possible with the language that you are picking. Okay, so what if the work that you're trying to do, you've picked C, you want abstractions but you've picked C as a language, you don't have any library at all which does that, so you will have to write the code. So that is the overall idea of levels of abstraction, that usually any language with a better library support, it can be considered to be at a slightly higher level of abstraction as compared to a library which has simpler library support. Is it getting through, right? Do you understand
Yes, sir.
what,
Yes, sir.
right? So this
Yes,
is the idea of level of abstraction. It is the how versus what part. If you are only if you are only considering the what part, you don't care about the how part, then you are at a higher level of abstraction in programming. If you also care about the how part, you are at a lower level of abstraction in programming. This is the idea. Okay, any other queries from today or yesterday? Again, these are all concepts, okay, don't worry. So there is really no clear cut way of saying that I am at a higher level and that person is at a lower level. These are all concepts, okay. Conceptually you have to think like this, that whether you care about the what part or you care about the how part, that is the idea. Okay, any other questions? Okay, then let me stop this. So your TAs will send you an email probably today, informing you that they are your mentors, and maybe tomorrow morning I can just send you, because it's completely offline this week, so it doesn't really matter. The idea really is to get accustomed to your, so have a good relationship with your TA. During the lab evaluations, your TA, your mentors will not evaluate you. Someone else will evaluate you during the lab exams. But throughout the semester, you will have one mentor, one TA as a mentor, and he or she will guide you through coding problems. That is the idea. Okay. Yeah, lab timings, Vanshdeep, this week they are going to be the same as timetable, but I'm trying to get these timings changed to a slot where the TAs can actually take, can actually sit with you for 2 hours online. For that, I have requested a timetable change. I don't know what exactly happened. I'll just follow it up again. But this week they are the same thing, and there won't be any classes this time. The lab is kind of offline because it's a practice lab anyhow. Okay. Oh, on 14th April. Oh yes, there is a. It has been declared a holiday, right?
Yes,
Oh
sir.
yeah. Okay. When I think on 14th April we had the lab exam, right? So we will have to see what to do with it. Yeah, that is what we'll see. So if the changes in the timetable go through, those lab exam dates will also change actually. I had to see the timetables, and I kept the lab exams on Wednesdays and Thursdays. If the timetable changes, I'll have to accordingly modify the date of lab exams also. It will be like plus minus one or 2 days, usually in the same week. But yeah, that 14th April thing I will have to see. We'll have to somehow compensate for it some other day. Okay. uh, because I don't want to engage you on the holiday, right? It's bad manners to engage students on holidays, unless it's absolutely required. So I will not engage you on the holiday. Enjoy it. Enjoy as in just stay at your home. The things are really getting worse outside, so stay at your home, but enjoy. Okay. Any other query? Okay, guys. Bye. Have a nice day.
Thank you very much.